So again, today is day 3 in Algebra 2. It is Wednesday, October 8th, and for your due now, you were given a worksheet with some substitution problems. And this worksheet was meant to help us review, but also introduce a couple of things that we haven't talked about yet. So if you got stuck on some of these problems, that is okay. I'm expecting most of you to not know how to do this yet. So you were supposed to just try to solve numbers 1 through 4, and then the timer just went off. So we're going to go over those answers. So number 1, what I'm going to do is actually write my problems out on paper just so that I'm not writing so tiny and you can see my work a little better. So I'll start by just rewriting number 1 on my page. And that system has one equation that is y equals negative 5x. And my second equation is 10x plus 2y equals 5. So when we are using substitution to solve an equation, what is a good first step for this problem?
Write down the 10x plus 2y equals 5.
Yep, write down that second equation again. That one's in standard form. 10x plus 2y equals 5. And what am I doing with that equation?
Trying to figure out what y is.
We're trying to figure out what y is. Do we know what y is?
We're trying to figure out what x is.
We're going to also be trying to figure out what x is. Yes.
You take negative 5x and plug it into the y.
Yes, thank you. Yes, that's what I'm looking for. We are going to notice, first of all, I've already got y by itself. Y is equal to negative 5x. I like to start by circling all my y values. Technically, even though this says x, it's equal to y. So this is the same thing as y. So any other y's that I have, like this y in my second equation, can be replaced with that negative 5x. We're going to substitute it for negative 5x. So I'm going to do what Charles was saying, where we rewrite that second equation, but we're also going to plug in negative 5x for y. So let's write that. 10x plus 2. I won't write y. I'll write
Negative 5x.
yes, negative 5x. And equals 5 is the rest of my equation. So what would I do from here?
Bring down your 10x and then distribute.
Yeah, we're going to distribute or multiply. We have 2 times negative 5x.
Negative 10x.
That's going to give me negative 10x. I'll cross that out. I'll bring down my 10x.
Equals 5.
10x minus 10x equals 5. What do I do next?
Subtract 10x from 10x, which would be x, so x equals 5.
Ooh, you're very close.
X equals 0. Oh.
X equals 5, x equals 0. Let's see what happens. First of all, I have 10 x's right here, and I'm taking away 10 x's. So 10x minus 10x. That's 0.
Well, yeah.
10 minus 10 is 0, right?
Yeah.
So I have 0x, really. Is anybody uncomfortable with that or not sure why that gives us 0x? X is 1 if there's no number in front of it, or if trying to think of a way to say it. Like if this was 10x minus 9x, if I start with 10 x's, I take 9 of them away, I have 1x left. But if I start with 10 x's, I take away all 10 x's, I have no x's left, right? Does that make sense? Like if x was, I'm gonna explain this in like the elementary way because sometimes that helps.
Negative numbers used to confuse the crap out of me last term. That was like the big thing.
Negative numbers confuse everybody. You are not alone there. So don't feel bad if you're a little confused right now. Let's get us found. Let's think of x as we'll just say that we have an apple here. I have 10 apples. All right. If I start with 10 apples and then I take 10 apples away, I subtract 10 apples, I eat 10 of them. How many apples do I have left? 0. So I have 0 apples.
In a way, you do technically still have 10 apples, they're just somewhere else.
Yes, they're in my belly. They're gone. They're breaking down. So if I have 10 x's and I take away 10 x's, how many x's do I have left? 0.
Would it be no solution?
Okay, so let's talk about this. So 10 minus 10 is 0x, but really this means 0 times x, which is just 0. Right? If I take away 10 x's and I start with 10, this cancels out. I'm getting 0. So 0, bring down equals 5. Those cancel. You can't have 0 x's. You just get rid of it. So this got rid of our x. Is 0 equal to 5? No. 0 is not equal to 5. So if we get a statement like this, this means it's not true. 0 is not equal to 5. So there is not going to be any number that I can plug in for x or for y that is going to make both equations true. I can try plugging any number in the world in for x. No matter what I plug in, this equation is not going to equal 5. Let me show you an example. I'm going to bring over that 10x minus 10x equals 5. Let's say I want to try 3 for x. So 10 instead of x, we'll put 3. I'm not solving for 3. I'm just giving you a random number for x. Let's put 3. So 10 times 3 minus 10 times 3 equals 5. 10 times 3 is 30. Minus 10 times 3 is 30. Equals 5. What's 30 minus 30? 0. Do you see how no matter what number I plug in for x, I'm always going to get that same statement, 0 equals 5? That's not true. There is no number I can use for x to make this equation true. Thank you, Charles. So when we get something like this, our answer is simply no solution. Hi, Jerry said. We just started on this new worksheet on the wooden table. We're just on number 1. So this is no solution, you guys. That feels uncomfortable because we're used to getting an answer. But sometimes this happens. Sometimes there is no number that we can use to make our statement true. I could try plugging into the other equations too. It's just simply not going to work. So I know that might feel uncomfortable. We're going to sit in that discomfort and move on to another one. We're going to see more of these come up. I want to ease your worries though, because this is something that I more so just want you to be aware of. I just want you to know that it's possible to get no solution. And we'll talk about that a little bit more in the future. But before I do move on to the second problem, do we have any questions about what just happened? We'll go ahead to number 2. Okay. Well, let's go ahead and I'm going to write number 2 from that worksheet, which number 2 has the 2 equations. First one is y equals 5x minus 24. My second equation is 10x plus 9y equals 4. So we are using substitution. The way that I'm giving these equations to you every single time, you're going to have the same first step where we're going to circle all of our values that are y or that are equal to y. And we're going to replace the y in that second equation with the other version of y, which is the 5x minus 24. So who can tell me what am I going to be writing for my first step of this problem?
I guess bring the 10x down
Mm-hmm.
and then plus 9 with the parentheses.
Yes.
5x to create 24.
Perfect.
Then a parenthesis and then a 4.
Perfect. Okay, so we just rewrote that second equation, 10x plus 9 times instead of y, I left parentheses because I'm going to plug in this 5x minus 24 because this is equal to y. So it goes here, 5x minus 24. And I just copied over the rest of the equation, equals 4. So I plugged in my y value. We substituted it. What happens next? Good. We're going to multiply 9 times 5x and 9 times minus 24. We're distributing. So what is 9 times 5x?
45x.
45x. We'll get a big number here. 9 times minus 24.
Negative 216.
Negative 216. Perfect. So I'm going to cross this out so I don't accidentally bring it down. And what comes down?
Bring down 10x plus and equals 4.
Perfect. 10x plus 45x minus 216 and equals 4. And at this step,
Add your x's. So it'll be 55x.
good. We're going to combine like terms here. And I'm going to draw a line through my equal sign because I found that was really helpful yesterday in keeping us organized. But what we are doing here is I see I have 10x and I have 45x. These are like terms and they're on the same side of the equal sign. So we're going to add those together. And what do we get when we combine those?
55x.
Yes, 55x. So I'm going to bring that down. 55x. Then what?
Then you're going to add 116 to both sides. 216 to both sides.
Yes. Now before I add 216 to both sides, I'm going to go ahead and bring everything down just to keep my work organized. We had minus 216 equals 4. And then Jocelyn, you said we're going to add 216, right?
Yeah.
Perfect. We're going to try to get rid of minus 216. So
55x equals 220.
good. So 55x comes down equals 4 plus 216 is 220.
And then we divide 55 to both sides.
Perfect. Then we just divide by 55 to get x by itself. Both sides.
And then x equals.
X equals, you said 4?
Yeah.
Perfect. We are going to get a solution for number 2. X equals 4. Did anybody get a different answer, or did anyone maybe solve it using a different order or a different kind of method? Or did we all do it pretty similarly?
Exactly the same.
Exactly the same. Awesome. Okay. All right, so we have X equals 4, but am I done solving the system?
No.
No. What do I need to do?
You need to plug in your 4 to the X for the Y.
Yes, yes. So now I'm going to use the X value that I have, 4, and we need to plug it in so that we can find our Y value. We're going to be plugging this back in to the Y equals equation. So we have Y equals, what am I writing?
5 parentheses with the 4
Good. 5, instead of X, we put 4.
minus 2.
Minus 24. Good. Okay. So everything's plugged in. I'm not solving anymore for anything. We're really just following our order of operations. I need to see multiplication and division probably need to come first, and then any addition and subtraction. What do I do first here?
Multiply 5 times 4.
Multiply 5 times 4, which is
20.
20. Bring everything down. Y equals 20.
Minus 20.
Good. Minus 24.
So 20 minus 24 would be negative 4.
Perfect. Y equals negative 4.
So your coordinates are 4, negative.
Yes. So your coordinate xy is 4, comma, negative 4 in parentheses. That is your answer for number 2. Good job. Okay. With this problem in particular, are there any steps that any of you may feel comfortable enough to share that you feel like you might be getting stuck on consistently, or any parts of this whole process that might be kind of tripping you up a little bit? Because odds are, if you're feeling that way, somebody else is too. And the goal here is to help each other out, guys. I want everybody to understand and feel good about it. I'll let everybody look for a minute. Tell me if there's anything that you don't feel confident about. If you feel really confident about this, give me thumbs up. If you are totally lost, give me thumbs down. If you're somewhere in between, give me like a middle. Okay, I can take that. I'll take that. That's good. So it looks like as a group, we could use a little more practice with stuff like this. But in general, we're doing pretty good. That's what it seems like.
Biggest problem, I get caught up in second guessing myself. I'm
Second
like,
guessing yourself.
I try to find it 2 different ways, and I'm like, what am I doing? And then I type it in on the calculator, and I get all these numbers. I'm like,
I get it. It's very easy to get ahead of yourself when you're doing a problem that has so many steps. Something that I find really, really helpful, and I'm happy to do this for anybody in the room. I like when I'm solving a problem like this with so many steps, I like to have this guide that we made out. And I'm happy to make copies of this for anybody that would like to have it on a separate paper. Sometimes what I would like to do is as you're solving it, like I'm going to literally go back and forth and check each step, make sure I'm writing it exactly the same way. So if I'm looking at my do now, let's see, here's my 2 equations, the y equals equation and then the x plus y equation, right? So I'm looking at my first step here and I see step 1, substitute, plug in to replace y with x minus 4. So I'm looking at my guide and I'm saying, okay, the y equals equation. I'm using the second half of it and putting it here. I'm going to do that same thing with this problem I'm working on now. Second half is 5x minus 24. I'm going to put it there. Then I might flip back and forth to this guide and say, okay, I did that. I've written it in. Step 2, what am I doing? Oh, in this one, I multiplied. I distributed. I did that 4 times x and I got 4x. I did 4 times minus 4, I got minus 16. So I'm going to look back here and see, what do I need to distribute here? Okay, 9 times 5x. And then 9 times minus 24. And I'll bring them down just like I did in my guide. Then if you get stuck at that point, I'm going to say, okay, let's look back at the guide again. We just did step 2. We multiplied or distributed. What did I do next on my guide? Oh, I combined like terms. And the like terms I combined were the minus 2x plus 4x, and I got 2x. So then I could look back at this problem that we're solving, and I'll say, look at this, it's just like that guide. There's an x and an x. I'm going to add them together just like I did in the example. I get 55x. Bring everything down. What if you get stuck at this step? Okay, I'm going to look back at my guide again. It might sound like it's getting old, but I'm telling you, the best way to make sure you're doing something properly is to do it very slowly. Do it very slowly, very intentionally. Double check every little step. And I don't want to say that it's a great idea to start over a million times, but if you ever get to a point on your paper where it is so unorganized, you don't know where you are, start over. That's okay. Sometimes it's nice to have a little clean slate to look at, to get kind of a fresh look at the problem. So I think the other thing is this will just get easier with more practice. Remember, we're on day 3. We're early in this. You guys are doing a really nice job for how little we've really done. Okay, that was number 2. Do we have any comments, questions, things we might want to talk about before we look at number 3?
Can you go back to your notes page for
Yes.
just a second so I can write down
Yeah.
that? These sticky notes, ever since I started using them, it's like essential. Like,
Right.
You need the sticky notes.
Love my sticky notes.
Uh-huh.
Here, I'll leave that up for a minute. Yeah, if anybody doesn't have this in their notes, this would be a great thing to maybe take a photo of, so that you can copy it down too. Other thing is, if you ever need, you ever want a paper copy of something that I have and maybe you don't, you can always ask me for it. I'm happy to make you copies. Yes.
Do you have to finish the packet with yesterday?
Did we ever finish that packet?
Okay, how?
Oh, do you have to? Nope, you don't. All the packets I give you in class are typically just for practice. And I don't grade your practice. The only things that I grade are things that I will have listed up on the board. And usually it's just exit tickets and attendance. So I don't grade a ton of things in here. Other than, yeah, exit tickets, quizzes, things like that. So practice is optional. You can do as much or as little as you feel like you need. All right. Did you see that one?
Yes.
Okay, perfect. No problem. All right. Let's go ahead and look at number 3 on that new worksheet. Yes, go ahead. So number 3, we have 3x plus 7y equals negative 11. Then I have y equals 3x plus 19. What should I do first? Plug in my y. I'm going to look at all my y values. Here's a y. Here's a y. Y is equal to 3x plus 19. So we're going to plug this into my standard form equation for y. Okay, so my next step is let's actually write this as being plugged in. I have 3x plus 7 times not y. I'm going to write the 3x plus 19 equals the rest of my equation, negative 11. Okay. Where do I go from here? Multiply. What am I multiplying?
7 with the 3 and the 7 with the 19.
Perfect. 7 times 3x, which is
21.
good, 21x. And then 7 times 19, 133. Perfect. Then I bring everything else down. And I'm going to cross out this part so I don't accidentally bring it down. 3x plus comes down 21x plus 133 equals negative 11.
You have the x's.
Okay, now I'm going to add my x's. Let's combine like terms. 3x plus 21x.
And 4x.
Good, 24x. Cross those out. Bring everything down. Plus 133 equals negative 11. Good, subtract 133 from both sides.
Negative 144.
Yes, negative 144. I'm going to bring down my 24x. Equals, and then you said negative 144. Just have one more step.
Both sides by 24.
Good. Divide both sides by 24. And we will get an answer of x equals negative 6. Everybody get that? And you want to get something different? Or did anybody do it in a different way? So we got x equals negative 6. Where do I go from here?
Still gotta find y.
Yeah, I still got to find y. How can I do that?
Take the answer that you had.
So I'm going to take that answer we just got. X is negative 6. Where am I going to put this to help me find y?
By the 3.
Yeah, right by that 3 in the second equation. So we use the standard form equation first. We plug into that. The ax plus by equals c. Then, once we've solved for x, we plug into our y equals equation, our slope-intercept equation. So I'm going to rewrite this equation as y equals 3 instead of x, negative 6 plus 19. So now what do I do?
Multiply 3 with negative 6.
3 times negative 6.
Negative 18.
Good. Go ahead. Thank you. Okay, so 3 times negative 6 is negative 18.
Plus 19.
Plus 19. And that will give us y equals 1. Good. Y equals 1. X equals negative 6. What is my coordinate?
Negative 6, 1.
Perfect. Negative 6, 1. Very nice. Very nice. That is number 3. Okay, I'm gonna leave that one up for a minute.
Sorry, I just want to cut it to this. 10, 45, no. Okay, so it's down.
So I'll leave that up, let you guys finish writing if you still need to. Everybody soak it up. And if you have any questions, let me know. So what did you do that's different on your paper? Everything. Wonder if I can see where you're getting stuck. Whenever you started solving your problem, were you able to get x equals 6, or are we getting stuck before then?
Well, what got me on the one that we just did,
Mm-hmm.
I added, I misadded on the 19 and 3x part.
I gotcha.
And I forgot the negative sign in the calculator when I was putting -11 to equal 1.
Those little tiny things will get you. Those little bitty things.
That's what always gets me with my ADD because I missed that one step.
Right.
Right. It's always something teeny tiny like that. Okay, so let's look at that number 4, the last one that I wanted you to try today. I'm going to copy that problem down here. Before we have 2 equations, y equals -9x minus 15. And then we have 27x plus 3y equals -45. This one looks a little tricky. Got some bigger numbers in there, some negatives.
Oh no.
Let's see what we can do. We want to start this the exact same way we've been starting the rest of the problems.
You want to plug in Y.
Yes, we want to plug in y. So what exactly am I plugging in and where?
Oh, next to the 3.
Next to the 3. Yep, we're going to replace this y. What am I going to replace this with?
-9x minus 15.
Yes, I'm replacing it with -9x minus 15. That's going to go right here instead of y. So let's rewrite our problem. And I'm going to rewrite it below so that maybe I can keep my print a little bit bigger this time, not have to zoom out so much. So I'm going to write that second equation again. 27x plus 3, not y, -9x minus 15. Equals -45. Okay, I plugged everything in. What do I do now?
Add the 27x with the -9x.
Do I do that yet?
You distribute first.
Ah, yes. So as soon as you plug in, you always have, I want to say not always, usually, if there's that number in front of y, we're usually going to be distributing right after we plug in every time. And we can always go back to that note guide. Let me pull that out one more time. Let's see. I need to have it on a separate paper. I see I just did step 1. I plugged it in, just like here. Step 1, plug it in. Step 2, multiply, distribute. Those steps will be the same every time. So let's multiply, distribute. 3 times -9x.
-27.
Yes, -27
Don't forget the
x. Yes, don't forget the x. and 3 times negative 15. What will that give me? Negative 35?
45.
45, thank you. And then I'm going to be very intentional and slow with this problem. At each step, I'm going to cross out the things I've done. I did my 3 times negative 9x. I did 3 times negative 15. I brought those terms down. That was step 2. We distributed / we multiplied. So now we want to think about step 3, which, looking back at my notes real quick, step 3 says combine like terms. After I bring everything down, of course. So I'm going to bring this down, 27x. We already have minus 27x, minus 45. Bring down equals, bring down negative 45.
Realize what's gonna be in the solution.
Let's see.
No, because they're both gonna be 0.
Okay, let's keep working this out. Let's see what happens. Let's see. If I combine like terms, let's talk about it. I have 27x minus 27x. What does that equal? 0. They cancel. 0x. It's gone. We're done with those. They cancel out. What am I left with? Okay. Let's bring that down. These are gone. So all we have left is negative 45. Bring it down, equals negative 45. Is this true? Yeah, this is true. Negative 45 is equal to negative 45. If I wanted to, I could take it a step further. What if I wanted to get rid of negative 45? I could divide by negative 45. I could add 45. I could subtract 4. I could do a million things. Okay, I could do a million things. I am, for the sake of this becoming 0, I'm gonna add 45. Are we okay with that? Just for fun. Add 45. Add 45. And well, both of these sides are gonna be 0. 0 equals 0. Is that true?
Yeah.
It is. We didn't have to do that next step, but I'm just showing you that now that we're at this point, I can do anything to this equation. Infinite solutions. That means no matter what number I choose for x, no matter what number I choose for y, it's going to work. It's going to work every time. So what our answer here would be is infinite solutions. That using the infinity symbol if you want. Infinity, it's like a sideways number 8.
8 is just a side of 35.
Or maybe that's the real truth. 8 is sideways infinity. I think.
Crazy, I can draw an 8. I can't draw an infinity.
Tell you what, it's so funny because I see some of the craziest looking infinity signs. As long as I know that you're not saying your answer is 8, I'll take it.
Okay. Pretty much whenever I would struggle to do it, I would always flip my paper sideways so that I could
There
just
you
draw it.
go. That's a good way to do it, too. I love it.
Right.
Okay. All right, guys. So the point of these problems this morning, specifically numbers, I believe 2 and 4. No, 1 and 4. Number 1, we got no solution. Number 4, we got infinite solutions. The main goal was to introduce the idea to you that sometimes our answer is not simply one answer or one number for X, one number for Y. Sometimes there's no answer. Sometimes there's infinite answers. So before I let you go to break, I will have us start a little note because I want us to make a note of this to help us remember in the future. But before I do move on to writing that note, does anyone need more time copying this? Happy to wait. Okay. Tell me to stop if you need it. All right, all right. So, very quick note page, and then I'll give you a break. I'm going to title this as Algebra 2, Unit 1. And these are our day 3 notes. It is Wednesday, October 8th. Make a little note that says when solving a system of equations, three possible outcomes exist. Is X equals a number and Y equals a number. That is when we write our answer as a coordinate. X first, and then Y. Second outcome is when we get a statement that is not true, such as 0 equals 5. That's not true. Or 10 equals 40. It doesn't matter what the numbers are. If I get two numbers equal to each other that are not actually equal to each other, or if my x's and y's are eliminated, if they cancel out and there's none left, there's no solutions. So let's see. I'm going to write example 0 equals 5. I'm also going to put a little slash through my equal sign to show it's not equal to 5. All right, not true. What we would write here as our answer is either no solution, or you can write what's called an empty set, meaning no answer exists. So I'm going to write both of those. No solution. And that looks like a 0 with a slash through it. Then our third possible outcome is when we get something like x equals x, or 5 equals 5, or 0 equals 0, or negative 45 equals negative 45, whenever you get a statement that is true. So I'll write again, example, 0 equals 0. True. It's true. Then write, here I'm going to draw a line between this, infinite solutions. You can also draw with the infinity symbol. That is all I need you to write for now. It is 10:14. I would love for y'all to take a little break if you need it. We will come back in 15 minutes. 10:30. I will begin the next part of our lesson for today. So, bathroom, drink, phone call, whatever you got to do. Now is a great time to do that, and I will see you guys in about 15 minutes. All right. So we're back from our break, and so basically during our first half of class, we just did that do now, the first 4 problems, and then we took this short little section of notes talking about the 3 possible outcomes when we solve a system of equations. We'll either get one value for x, one value for y, or the second and third options, you're not going to really get a value for x or y. You're going to get a statement that is not true when there's no solution, such as 0 equals 5. That's not true. Or you're going to get a statement that is true, such as 0 equals 0, or infinite solutions, meaning you can use any number and it will work. So we're just going to keep these 3 outcomes kind of in the back of our mind as we look at another method of solving systems. So we focused on substitution, and what I'm going to do right now is I'm going to flip back in my notes to page 2 for day 2 notes, the first page of that. And this is where we kind of wrote down the equation forms, and we wrote down all the steps for substitution. So I'm going to add a sticky note here that I'll carry over to my next page. And I'm going to make a little note. First of all, actually, before I do that, I'm going to rip one of my sticky notes in half. And I'm going to use this as a bookmark because I've noticed we flip back to this page quite a few times today. And so I'm going to write here steps for substitution. That way I know I can always flip back to it. This is another way your notes can be even more helpful for you is if you give yourself little things that help you remember where things are, like a tab. That's obviously completely optional. You don't have to put tabs on your thing. But what I'm going to do is I'm going to write down on my sticky note now those equation forms to bring over to the next page. We have the ax plus by equals c. And we have y equals mx plus b. And that top one with ABC is standard form. So I'm just going to write standard. And then my bottom equation, slope, intercept. I'm gonna abbreviate intercept and just write INT. Okay, so I'm gonna go ahead and take this note up and we're gonna flip back to our day 3 notes that we just started. I'm gonna keep this kind of to the side over here. So when we solve a system of equations that has 2 equations with a standard and a slope-intercept, so we've got one of each, we're usually going to use substitution to solve, just like we've done in all of our previous examples. There's always been one equation with x and y together. There's been one equation with y equals. So elimination is a little bit different because when we use this next method we'll talk about, you are not going to have an equation in slope-intercept form. You're going to have 2 in standard form. Let's make a note. I'm going to use red. I'm going to write the word elimination. E-L-I-N-A-T. Elimination. And I will give you an example of a system that can be solved by elimination. Let's pull one up real quick. You get make one up on the spot, do it wrong. Okay, so let's start with one like this. My first equation is going to be x minus y equals 2. My second equation is going to be negative 4x plus y equals 1. So I've got my 2 equations in my system. We'll notice right away that neither of these equations starts with y equals. These are both in standard form. We have an x, a y, and then our equal sign. So we know that when we are solving an equation or a system or doing anything where there's an equal sign, if I do something to one side to keep that equal sign true, I need to do that to the other side as well. So for example, if I add 1 to one side of an equation, I have to add 1 to the other side. I have to keep it even. So I want to introduce something to you. If I look at just my first equation, x minus y equals 2, it doesn't look like there's anything that I could add to both sides that would cancel out one of my variables. There's nothing I could subtract. There's nothing I could multiply. There's nothing I could really divide. But what if I keep in mind that right here in my second equation, it says negative 4x plus y equals 1. That equal sign tells me that whatever is on the right side is equal to whatever's on the left side. It means they're the same thing. So negative 4x plus y, this is the same thing as 1, correct? Because of that equal sign, I know that 1 is the same thing as negative 4x plus y, whatever that is. It's the same thing as 1. So what if What if I add 4x plus y, or negative 4x plus y, to one side of my equation, and I add 1 to the other side? Technically, I'm adding the same thing to both sides because this equal sign says that these are the same thing. Stay with me. Here's what I'm going to do. Instead of moving anything around, I'm going to draw a line. I'm going to treat this like a big addition problem. I'm going to put a plus sign here. What if I go up and down on each term and I add everything together? Let's see what happens. If I look at my x's first, I have x plus negative 4x. Negative 3x. Good. So I'll bring that down. Negative 3x. Done with my x's. Now I'll move to my y's. Negative y plus y. 0. They cancel. This is where elimination happens. We are eliminating the y. It's done. We're done with the y. Okay, so now I bring down my equal sign. What's 2 plus 1? It's 3. Good. Now I have an equation that says negative 3x equals 3. Can I solve this? I can. I can. How do I do it?
Negative 3 divided by 3.
Yes, we're going to divide by negative 3. So get rid of the negative 3 on my x. I'm going to do that on both sides. That cancels. I'll bring down my x equals negative 1. We just solved for x. That wasn't so bad. We just added the equations together. We eliminated our y. We solved for x. So now I have an x value. When we use substitution, once we found our x value or we found our y value, what did we do to find the next answer? Plugged it in. Guess what? You're going to do the same thing here. Does it matter which equation I plug into? What do we think?
I would do it with a 4.
You would do it with the 4x one? Okay, we can try that. How about we do it to both and just see what happens? Let's see if it makes a difference. We'll make sure at this step. So I'm going to rewrite both of these equations. I have x minus y equals 2, but instead of x, we're putting negative 1 because I know x is negative 1 now. So x minus y equals 2. And then I'm also going to plug into my, so I can write both. Negative 4 times, instead of x, I'll put negative 1 there, plus y equals 1. And I'll write my x value in, negative 1, negative 1. We're going to do it with both equations. Distribute. Which one are we doing? The negative 4?
Yeah.
Yes. So if I'm looking at my second equation first, the first thing I need to do here is distribute negative 4 times negative 1. What will that give me? 4, positive 4. Negatives cancel, and I'm left with 4 plus y equals 1. And I'm still trying to solve for y.
Subtract 4.
Good. We'll subtract 4 on both sides.
Y equals negative 3.
Perfect. Y equals 1 minus 4. That is negative 3. Okay, so we got negative 3 for y when I used the second equation. Let's make sure we get the same thing when we do the first equation. So now on my first equation, I plugged in my x value that was -1. I replaced it with x, or I replaced x with -1. So now I have -1 minus y equals 2. What could I do here?
Add one on both sides.
Add 1 on both sides?
-1, take away 1.
-1 take away 1?
Negative.
What do you mean -1 take away 1?
Well, I'm over here with the 1, -1.
Right here?
Yeah.
Okay. So what are you saying? -1 take away 1?
Oh, I thought I'm on stuff.
Oh, okay. You're all right.
Would be add or add -1 to the 2,
Yeah.
but it's in parentheses, so
So-
that's freaking me out.
Okay. Parentheses. They freak us out. That's okay. So basically, let's look real quick over here. When we distributed, we got rid of the parentheses. If there's nothing to distribute, do you need the parentheses?
No.
No. I just wrote the parentheses to show you that we plugged that in. So if it makes you feel better, we can just rewrite it without the parentheses. -1 minus y equals 2. Now what do I do?
Add 1 to both sides.
Add 1 to both sides. Yep, let's add 1. My 1's cancel. Now I have -y. Don't lose that minus. It's minus y.
Sometimes I like to put a 1 in
That's smart. That's smart. If you're worried that you'll lose that minus, sometimes seeing a number helps. Remember, if there's no number in front of your variable, that number is 1. So really it's -1y. So this is -1y or -y. I'll put a 1 there. I'll bring down my equal sign. 2 plus 1 is
3.
3.
And then you divide negative
Yes.
by both sides, so your answer y is negative.
Yes. So y is still not by itself. We have -y. If I want positive y, I need to divide by -1, which is going to change this to positive y and change this to -3. So let me write all that. -1. Get y equals -3. And look at that. It worked for both equations. We got the same answer of y equals -3. So when you are solving systems with elimination in the future, you don't have to do both equations like this. Once you have your x value, you just need to plug it back into one of the equations. It doesn't matter which one because we just found out you're going to get the same answer regardless. It will work whichever one you choose. It'll work. So that's just our first little example. I'm going to show us a few more, and then just like with the substitution, we'll write out some steps for elimination as well. We'll write out some steps. So if it's not clicking just yet, don't worry. Sometimes it just takes a few problems for it to make sense. Before we do any others, though, do we have any questions about any part of this process? All right, I'm going to show us one more. Let's see. Let's do x plus 5y equals -15. And my second equation is -x plus 4y equals negative 12. So just like in the problem we did right above this, with elimination, your first step is really to just have your equations written on top of each other, and we're just going to treat it like a big addition problem. I'm going to add everything. Yes. Go ahead. So I have my equations written on top of each other, and we're going to look at one term at a time. Basically, what we're doing here is we're like combining like terms, but vertically. So I'm going to add this equation on top to the equation on bottom. First, I have x plus negative x, or x minus x. What's that?
0.
0. It cancels. We eliminated the x's this time. 5y plus 4y. 9y. Bring down equals. Now I have negative 15 plus negative 12.
Negative 27.
Good. Negative 27.
And divide the 9 on both sides.
Good. Divide the 9 on both sides.
And y equals negative 30.
And y equals 27 for negative divided by 9 is negative 3. Okay, so step 1, add the equations. Step 2, solve. Done that. I have my y. How can I find my x?
Plug in negative 30 to one of the y on either equation.
Yes, we're going to plug in the negative 3 that we just found into either one of the equations. It does not matter which one. Both of them will work. The only thing that we need to be very, 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 very careful of is we're not always solving for x first. Notice how in this problem we got x equals negative 1. This time we found a y value. Don't plug in negative 3 for x. This is a y. So be careful. Replace things in the correct spot. Which equation do we want to use? It doesn't matter, but what are we thinking?
X plus 5 times negative 3.
You said x plus.
5 times negative.
Okay, perfect.
Equals negative.
Perfect, perfect. We'll use the top equation. X plus 5 instead of y, negative 3. Perfect. Equals negative 15. So I just plugged that in for y. So I'll even draw a little arrow to show that's what we did.
5 times negative 3 equals negative 15.
Perfect. 5 times negative 3. Next step we're distributing is negative 15. Bring everything down. X minus 15 equals negative 15.
Add 15 to both sides.
Okay, add 15 to both sides.
Negative 15 plus 15 equals 0. Same for x is 0.
Negative 15 plus 15 does equal 0. So x equals 0. Excellent. What would my coordinate be?
0 and negative
0, negative 3. I forgot to do that on the last one. 0, negative 3.
Negative 3.
Perfect. You are correct. Last one would have been negative 1, negative 3. All right. Any questions about anything we just did?
Doing it this way seems a little bit easier
Good.
than the other way.
I find that most students will agree with you. Most people like elimination better. But it's funny, everybody, your brain works a little different. Some people do like substitution better. It just depends. Depends.
Can you tell me the steps again?
The steps, yes, we are right about to on the next page. We're gonna write out all the steps just like we did for substitution, and we'll do that real slowly, and I'll give you like word phrases to put down. So if you're okay with waiting just a second, we're gonna do that together. Before we do that, does anybody still need to see this problem, or can I flip my page? Title my notes. Algebra 2. This is still our day 3 notes. Page 2. And I'm going to write elimination again at the top, and now we're going to write out some steps that we can look back at. Now, right beside the word elimination, I am going to write real small in parentheses, no multiplying. This won't make a ton of sense to you today, but it will later, probably tomorrow. Well, maybe next week. That's a good note to make. No multiplying. The example that we will work with for this step guide, I'm going to give you another equation. We'll start with negative 5x minus 3y equals negative 6. And my second equation will be x plus 3y equals negative 6 again. So, step 1. We're going to start by adding the equations together. I'm going to add all the terms together. So, add both equations. A line here, putting a little plus sign, and we will start with the x's, then the y's, keep the equal sign where it is, and then we'll do our non-variable terms. So that's step 1. We're going to add both of our equations together. And what am I adding first? My x's. Yes, negative 5x plus x is negative 4x. Okay. Then what? Add your y's. Add my y's. Negative 3y plus 3y. Yes, they're going to cancel. They're going to be 0. If I have the same number, the same variable, and just different signs, those are always going to cancel out. These get eliminated. Bring down my equal sign. And now I have -6 plus -6. What is that? -12. So -4x equals -12. Now a side note for step 1, add both equations. I'm going to write one of your variables, in this case our y value, one variable will be eliminated. We just eliminated the y's. A little kind of side note for step 1 is we've added our equations together. Now we're going to continue this as step 1. We need to get that x or y, depending on what we eliminated. We're going to get the remaining variable by itself, which honestly, that should be step 2. If we're being specific about it. So I'm going to write step 2, solve / get the remaining variable by itself. So how can I do step 2? How can I get x by itself?
Divide both sides by -4.
Divide both sides by -4. Perfect. Perfect. I have -4 times x. We'll do the opposite. Divide by -4. And my -4's cancel. Bring down x. Bring down equals 3. Good. So step 2 is done. I got the remaining variable by itself. We solved for x. Once you have solved for one variable, step 3 is going to be to take that number that we just found and plug it in to either equation. It does not matter which one. So let's write that. Step 3. Plug in the value you just found plug in the value you just found to either equation. Doesn't matter which one. So whenever I'm trying to decide which equation do I want to use, I'm going to use the one that looks easier to me. I'm going to look for the ones with smaller numbers with less negatives. Which equation do you think we should use?
X plus 3y.
Oh yeah, that's what I was thinking. Let's use the bottom equation. X plus 3y equals -6. So I am going to write that x plus 3y. -6. And I just rewrote that equation. What am I plugging in?
The X.
My x. Instead of x, I'm writing 3. So we're going to write 3 plus 3y equals -6. Okay, so I plugged it in. Yes. Now, before I continue this, if we're trying to create our guide, I'm going to write step 4 at this point. We plugged it in, and now we're going to, again, solve or get that other variable by itself again. We're just solving again. So I'm going to write that real quick. Solve. Other variable by itself. So we will do what you just said. We'll subtract 3 from both sides. Perfect. Those cancel. We bring down 3y equals -6 minus 3 is -9. And what next?
Divide by 3.
Yeah. Divide by 3 on both sides.
Y.
Perfect. Y equals -3. I solved for x. I solved for y. My very last step to write your answer as a coordinate, and that's it. So what would my coordinate be in this case?
3 and -3.
Yes, 3, -3. All right, okay, so we've made a little guide. And we can use this to look back at when we're solving other problems. I'm going to leave this up for a minute. I know that that was a lot to write all at once. And we're going to do some more practice with this after I give you guys a minute to copy down. So I'll pause that for just a moment. So let's do some examples of this. I am also going to take the other half of that sticky note I wrote earlier, and I'm gonna bookmark this page because I bet you I'm gonna need it later. Elimination. Never a bad idea to do things that you know will help your future self. So I'm gonna flip my page and I'm gonna title this again. Day 3 note continue. Is a grade. And what I'm gonna write underneath this title is elimination practice problems. That's what we're going to be doing here. So, I'm gonna give you a few more problems here. Four minus three equal -1 and -4x minus 4y equal 8. Here's our first problem. I would love to run through one more together as a class, and that's going to be this one. And then I do want to have you guys try to do some on your own after this and see how we do. So before you do it on your own, this is a great time to stop me, ask questions. If you are unsure what I wrote, tell me, and I can try my best to explain. And of course, if you're feeling confused and lost, I'm here to help. Right? Now, whenever we do some problems on our own, I'm always here to help one-on-one as well. I know sometimes it's not as easy to ask a question in a big group. So know that I will be available after we do this last problem together. So go back to your guide if you need it, or if it, finds it to be useful for you. But what is my first step? Yeah, add my equations together. So I'm going to draw a line with a little plus sign. And 4x minus 4x or plus negative 4x.
They cancel.
They cancel. They eliminate. Now I have negative 3y plus negative 4y. Ooh.
I know it's 7 for me.
So let's see. If I have like negative $3 in my bank account, and then I add a charge gets added where I paid $4 more for something. Is my bank account going to be -7 or +7 now?
Negative.
It's going to be -7. When you add a negative number, that negative gets bigger. It's going to be a bigger negative, which is technically a smaller number, but so it's got less value, bigger number.
No, if only money worked the other way.
Right, I wish. Negative 3y minus 4y, that is negative 7y equals -1 plus 8.
-7.
If I have negative $1 in my bank account and then I add $8, we're going to cross past that 0. Yeah, now we'll have +7. Now, these little positive and negative rules, so easy to forget them. Don't be afraid to rely on your calculator. I wouldn't put it past me to type 1 + 1 = 2 on my calculator because you never know. I like to rely on it. So we're going to get +7 here.
Divided by -7.
Perfect. We'll divide by -7.
And 1 will equal -1.
Wonderful. Y equals -1. Okay, so I got my Y.
Okay.
Plug it in. I'm going to use the top equation because less negatives. Well, I guess the same amount of negatives. Technically. Whatever. I'm gonna
Does
use
it matter which one you use for?
No, it does not matter. You can use either one. You will get the same answer. You will get the same answer. So I'm going to write 4x minus 3.
And for this is -1.
Yes.
Equals -1.
Instead of y, we're putting -1 equals -1. And what I'll do, I don't know, sometimes colors are helpful. I'm gonna only make orange the thing that I added in, the -1. The rest of that came from the original equation. Before I move forward, is there any part in this process that anybody's not sure about? You guys are gonna get annoyed with me asking that.
Are there new people in this class? Like anybody that's new?
Oh, is there anybody that is new to the Excel Center? I see faces that I don't recognize just because I
Are
haven't
you new?
had yet.
Girl, I asked some questions. I was scared to ask them
I
in the first
understand
2
it.
weeks. Yeah, for anybody else that's scared, just do it. It's
Right.
fine. We're all probably a little confused.
Oh yes.
It's fine.
I promise you, anytime that you're feeling that way, like you just said, there's probably at least one other person in the room that is feeling exactly the way that you feel. I know it can be scary to ask questions, but I am not somebody that will ever be mad if you ask a question. I don't get frustrated very easily. My favorite part of teaching is when you guys ask questions. So it will probably make my day more than anything if you
I
ask
feel
a
like we all have
question.
there's a no stupid questions policy.
Yes.
Like, I have never heard a teacher respond to a student in a way that was condescending or like, oh, you don't know that. Even if it's something that would be considered simple, like
Right.
all of you guys answered so like in depth to reteach
Wow,
them.
that is awesome. I
I
love
love
that that's been your experience.
Yes.
And that's what your experience should be. I think a lot of us are partially traumatized
Yes.
from our previous high school experiences, having teachers that are not understanding. That when you don't understand something, there isn't much effort on their end to make sure you understand. It's more of you're looked down on, or you're just going to get left behind. I won't be that teacher, guys. I won't. I want you to understand. And if you don't, sadly, I'm not a mind reader. I wish I was. That'd be like really cool if I could read all your minds. But I can't. So tell me what's on your mind. Tell me if I can help you. I want to help you. I won't ever be mad. Okay, so I have 4x minus 3 times -1 equals -1. What do I do? Good. Multiply -3 and -1. And yes, these negatives will cancel. Charles, were you about to say something?
Nah, I had like a blooper moment because I was going off the not multiplying like we talked about.
Uh-huh.
And then we multiplying.
Oh, are you talking about the guide we just made?
Yeah.
We didn't have a multiplying in this problem, did we? Okay. Let me make a note. Sorry, guys, we're gonna flip back. So this is a special case. I picked a bad example, I guess. On step 3, after you plug in the value you found, which is the step that we're on here, we just plugged in our value. In our first example problem, it says to go ahead and solve after you plug in. I want to add a side note that if there is a number in front, we need to distribute or multiply first. Okay? We need to distribute or multiply before you solve, which doing that distribution is technically part of solving here. But sometimes having that step written down can help. So I'm going to add that in as a little side note for step 3. Once you plug in the value, distribute if necessary. Kate mentioning that.
Yeah, no problem. Because I just, like I said, I was like, huh?
Right.
I was going off the not multiplying. But
Yes.
I didn't realize.
So after we plug in, we need to make sure that there's nothing that needs to be distributed, nothing that needs to be multiplied. So we just plugged in, we just distributed, we multiplied. we said that -3 times -1 is +3. So I'm gonna bring down that +3, and I'll bring everything else down as well. So what comes down?
4x.
Good, 4x,
Equals -1.
and then my equals -1. 4x plus 3 equals -1. Now we can solve. Subtract 3, good. Set out. -1 minus 3 is -4. Good. Bring down 4x.
Divided by 4.
Good. Equals -4. And then just like you said, to get x by itself, we divide by 4. Perfect. We will get x equals -1. Okay. So I have x, I have y. Am I done?
You gotta make your coordinate.
My coordinate. What is my coordinate?
-1 and -.
-1, -1. There you go. That's your answer. That's your answer. Okay. Guys, I'm looking at the time right now. It's 11:26, which technically we have until 11:55. That means was like 25 minutes that I still technically have you. Here's what I am thinking for the rest of class. I am going to display some problems on the board that you guys are welcome to work on as practice by yourselves, but I'm gonna go ahead and make our exit ticket for today. So if you feel good about this, you're ready to start on that exit ticket. As soon as I have it up and displayed and I can get copies to you, which will be in the next 5 minutes, you are welcome to complete that and you're free to go. If you would like to stay, because we still have close to 30 minutes, if you'd like to stay and get a little more help or get more one-on-one help from me, please stay. Please stay. I'm happy to help you. So, let me make the exit ticket, but also I'm going to put some problems up here so that you're not just sitting there.
And you want us to keep these in our folder for old exit tickets, or you want it?
Once you finish an exit ticket, put it in the turn-in tray so that I can grade it, and then you can keep it in your folder.
Okay.
Oh yeah, make sure your name's on it. By the way, if you did your exit ticket yesterday and the graded one is not in your folder, I've graded all of them. Up there on the wooden table where the worksheets are, somebody has an exit ticket that is written in orange ink, and they did not write their name on it. So if you could come claim that so I can give you your grade, that would be wonderful. All mine are running out of ink.
You guys be writing a lot.
I know. Okay, let me freeze my screen. I'm gonna leave this problem displayed for you to work on, and I'm gonna create your exit ticket. And I'll bring those back to all of you here in just a minute or two, so that you can get started on it. All right, so this is your exit ticket for today. I'm gonna run copies for you, but other than that, that is it. If you would like more help before trying your exit ticket, you are welcome to stay and talk with me. Just let me run and make those copies first. The end.